recording. All right, so I'm going to show you five types of reactions. These are general categories that a lot of times are helpful in predicting what kind of products you're going to get. So the first one I want to talk about is something called a double replacement. And we'll spend a lot of time on double replacement reactions. It's going to have a general formula of a compound AB plus CD. And then what's going to happen is the A is going to go with the D. So A combines with a D, and C then combines with a B. So it's sort of a switcheroo. So the A right here is going to go over and link up to the D, and the C is going to come back and link up to the B. What's happening is these are always ionic equations. Okay, so they always involve ions, and the cation is going to be the positive, and the negative is going to be the anion, and they're going to go back. So that's what's putting them together, is the positive negative, because over here we had this was A here was positive, B was negative, C is positive, and D is negative. So they're switching around. So that's the first type of reaction. The second one is going to be a single replacement. And I'm going to, after I show you these, we're going to come back and look at them, a couple of them in a little more detail. But right now this is just the basic idea of how these are going to go together. So in a single replacement reaction, I'm going to have a lone element, and it is going to react with a compound producing new substance, and that's essential for a chemical reaction to take place, is you got to end up with new stuff, and it's going to look like that. So in this case, A right here is going to knock off B. A is going to then combine with C, forming AC. B is going to be all by itself, and this is going to be a single replacement reaction. All right? So here are three more, I guess. This reaction is called a decomposition. Decomposition. And sometimes it'll be referred to as an analysis reaction. That's a Y right there. Okay, so analysis. And the form it's going to take, let me see, okay, is you're going to have this compound, AB, and it's a decomposition, so it's one thing. What's going to happen is it's just going to break apart into A plus B. Now, sometimes with this shorthand notation it's misleading, because you think that A has to be just one element in a decomposition. It doesn't have to be that way. It can be a clump of elements put together in chemically bonded covalently or whatever, but you're going to end up with one chunk somehow forming two chunks out of it. And that then you would look at it and say, okay, that's going to be a decomposition. The next one is the opposite of a decomposition. It's called a combination. And I'm going to go through and give you examples of these in class so you can see what's really actually happening. It's also referred to sometimes as a synthesis reaction. And like I just said, it's going to be the flat out opposite of what I just drew up there, where in this case I'm going to have an A plus a B, and they're going to go together, in this case, to form AB. Alright? Now the last one kind of has pretty important implications with global warming and all sorts of things, but it's called a combustion. And a combustion reaction always is going to involve what's called a hydrocarbon. or usually, I guess you can, but it's going to involve hydrocarbons. And hydrocarbons are, pretty much what's, a lot of this world is made up of. But they're going to be compounds that have both hydrogen and carbon in them. They can be a little bit more complicated with oxygens and nitrogens, but the foundation of a hydrocarbon is a structure of a covalently bonded molecule that includes hydrogens and carbons. So an example of a combustion reaction, so what's going to happen is that hydrocarbon is going to react with oxygen, meaning it's going to burn, and I am always going to get two products. I'm going to get carbon dioxide and I'm going to get water. And it's this fact that carbon dioxide is produced that's a greenhouse gas. It's heating up the world just by straight chemistry. There's no getting around it. Anytime you burn a hydrocarbon, which includes fossil fuels, oil, gas, coal, wood, you're going to produce CO2 in quite a bit, a big chunk, or a lot of CO2 is going to come out, and that's going to affect what's going on. So here's an example of a combustion reaction. Pretty simple hydrocarbon, that I'm going to take this is methane, okay, CH4. I'm going to burn it, so the other reactant in this process is O2. And I'm sitting there going, oh golly, gee whiz, I don't know what I'm going to get out of this. Well, yeah, I do. I'm going to get CO2 and H2O. And I will always be able to balance this reaction. I can always balance it. In this case, I'm looking at it, and I have one carbon. Well, I got one carbon there, so that's good. I have 4 hydrogens, all right? Over here, I only have 2 hydrogens, so I'm going to get the ball rolling by putting a 2 in front of the H2O. And this is a little bit of review on balancing, but remember that when you balance reactions, all you can do is change the relative number of each one of the substances, and you do that by putting coefficients in front of it. So now I have 4 hydrogens. I got 4 hydrogens over here, so that's good. I have one carbon. I have 2 oxygens here from the water, and I have 2 more from the CO2, so that makes 4 oxygens. To get 4 oxygens out of this, on this side of the equation, I'm going to need to put a 2 in front of the H2O. So at this point, I have balanced the equation. I have one carbon. I have 4 hydrogens. 2 times 2 makes 4 hydrogens. I have 4 oxygens. 2 oxygens from the water, the other 2 from the CO2, and that balances it out. So these are very simple explanations for, or kind of putting things into categories that will help you predict what products are going to be out of chemical reactions.